So the big science of the 18th century, the thing that required empire in order to establish is the astronomical unit. In 1680, Edmund Halley was able to tell us the relative distances from the planets, so we knew how long it took the various planets to circle the sun. But we didn't know how far apart they were. And in order to have accurate celestial navigation, we really needed to know that last number. Fortunately, in 1761 and in 1769, we have sort of an eclipse. Venus is going to pass between the Earth and the Sun and cast a shadow. And we're going to be able to see that shadow as it crosses the surface of the Sun. And if we can measure that shadow in different places and the length of that transit in different locations far apart, we can, through basic trigonometry, establish how long the legs, how far Earth is from Venus and how far Venus is from the Sun. But in order to do that, we have to not be close. We can't do as Joseph Rittenhouse did. We can't be in Philadelphia and in Dover. No, we have to be all over the world. So the British Navy will dispatch crews to Tahiti, to Johannesburg, to northern Canada, to Philadelphia, to the northern part of California, and they'll establish observatories. The Royal Academy of Russia will establish observatories in St. Petersburg and in Moscow, and the French, of course, will observe from Paris. And when we compile all those numbers together, we're able to observe different transits at different locations and see different paths that the sun, that the shadow of Venus as it crosses the sun. And from that, we are now able to calculate the distances. It took us several years to do that because we're going to use state-of-the-art calculators, like this Gunter's rule here, which works by adding logarithms. So if I add log 2 to log 3, it's like multiplying 2 times 3 to get 6. So the calculations are going to be tedious and they're going to be manual. But over the course of about 5 years, the Royal Academy is going to be able to establish the astronomical unit as 93,370,000 miles. That number will stand until 1968, when NASA will measure it again at 93,995,809 miles, a difference of 1%. So the most important scientific tool of the day, however, is not the telescope or the various measurement instruments that we'll use, but it's the lowly pen. By using by writing letters and correspondence and data to different places, we're able to publish through the Royal Academy. And if you remember when I was talking to you about the transit of Venus, there was this fellow in St. Petersburg was looking at the transit data. And he had multiple observatories in St. Petersburg. Cook had multiple observatories as well. And when we have multiple measurements, of course, we have a little bit of experimental error. But the interesting thing was the error in St. Petersburg, and the error in Tahiti, and the error in Paris, and the error in Philadelphia was almost exactly the same. And so Vladimir Slivets was able to look at that data, and he observed and dug deeper into it and found there was a haze around Venus. And so the observations were absolutely 100% accurate. It's just that they didn't agree on what was the edge of Venus, because Venus has an atmosphere, which then allows him to speculate. After reading here about the great atmosphere around the aforementioned planet, one can say, and we can presume, that because the vapor updrafts, clouds gather, rains fall, flowing streams would occur. Now this is complete heresy. The church will be very upset. Exact science will not be appreciative of what he's writing here. Will flow into seas and different types of plants will grow. He's saying that the earth is not the center of the universe. It's not the center of the world. It's not the only place that, according to him, the Creator may have placed great beings. So we know from Newtonian physics that an object in motion will remain in motion in a straight line. But it may surprise you that this pendulum here is actually moving 23,000 miles an hour right now. which is why when I swing it, it doesn't move in a straight line. It's being acted upon by the Coriolis effect as the Earth spins, and it begins to spin and rotate itself. This is how we determine the actual circumference of the Earth to be 23,000 miles, 323,650 miles.